Okay, well, happy December, everyone. I'm Chuck Friedman. I'm the chair of the Learning Health Sciences Department here at the University of Michigan Medical School, and I'm one of the three co-chairs of the Learning Health System Collaboratory, along with Doug Van Houweling and now Ed Hurwitz, who, as our clinical champion for learning health systems, has joined the collaboratory as one of its three co-directors. We really appreciate you joining us today. Today's session, as are all collaboratory sessions, is being recorded. The slides and the recording will be available on the collaboratory website archive just as soon as we have it ready and installed on the site. Today, we really will appreciate your questions, and I'm sure they will stimulate an excellent discussion at following what will certainly be an excellent presentation. We're going to use the Q&A pod for you to enter your questions. You can enter them anytime throughout the presentation, and you'll find that the chat has been disabled, so please use the Q&A pod instead of the chat. Our speaker today is Dr. Peter Embi. He will be speaking on informatics-enabled learning health systems, and I think you'll soon see, as the talk unfolds, the meaning of the "now it's personal" part of the title of the presentation. Just to say a few words of background about Dr. Embi. He serves as professor and chair of the Department of Biomedical Informatics, professor of medicine, and senior vice president for research and innovation at Vanderbilt University Medical Center. He began these roles in January of 2022. He's an internationally recognized researcher, educator, and leader in the field of biomedical informatics. He has authored more than 160 peer-reviewed research articles, abstracts, books, and book chapters. His areas of interest include, in addition to informatics, focused on clinical applications, research informatics, public health informatics, and of course, data-driven learning health systems. He earned his bachelor's degree from the University of Florida and his medical degree from the University of South Florida in Tampa. He completed residency, chief residency, an informatics fellowship, and a Master of Science in medical informatics and clinical epidemiology at the Oregon Health and Science University. Prior to his move to Vanderbilt, Dr. Embi was the president and CEO of the Regenstrief Institute, professor and associate dean for informatics and health services research at the Indiana University School of Medicine, associate director of the Indiana CTSI, and vice president for learning health systems at Indiana University Health. He also previously, and I'm very proud to tell you that he held leadership roles at the Ohio State University, where he was interim chair of the Department of Biomedical Informatics and associate dean for research informatics for the College of Medicine. Peter and I have exchanged text messages during certain football games for the last several years. In recognition of his contributions to the field, Dr. Embi has been elected to the American College of Physicians, the American College of Medical Informatics, and the International Academy of Health Sciences Informatics. I know you're going to really enjoy and learn from Dr. Embi's talk, and I will now turn the presentation over to him.
Thank you, Chuck. Thank you for that very kind introduction, and particularly for the parts where I know you really worked hard to celebrate my time at the Ohio State University. But in all seriousness, I really am honored to be here, and thank you for the invitation, and thank you all for joining today. So as Chuck said, I'm going to talk about informatics-enabled learning health systems. Now it's personal, and I'm going to go ahead and dig right in. It's often beneficial when we're doing these presentations to start with a case. Oh, I guess I should say first, with regard to this presentation, I don't have any disclosures. Starting with a case is often very helpful to sort of anchor us in terms of what we're going to be talking about here. And the case I want to talk about is actually one that yesterday was the 6th anniversary of, and that was my case. This is me, not feeling nearly as good as I'm pretending to look in that picture, about to be wheeled into the operating room for surgery. Again, yesterday was the 6th anniversary of this operation. A couple of months before that, I had started to experience what are called paroxysms, these acute episodes of really, really terrible symptoms, with a very severe headache, worst headache of my life. You know, if there's something higher than 10 out of 10, that's what I was feeling, with this sudden onset of these episodes with profuse sweating and pallor and palpitations, a feeling of panic and anxiety, flank pain, nausea, tachycardia, and severe hypertension once my blood pressure was taken of I think it was up to 220 at one point, systolic. And I had years of symptoms leading up to this that I had sort of explained away as just a variety of different things. I was ultimately discharged from the emergency room where I presented after this episode with hypertension and atypical migraine. And I went back home to Indiana and continued to have these spells. I had 4 additional ones and saw a neurologist for my atypical migraine, and was told at that time that it was likely instead occipital neuralgia, because of the nature of it being in the back of my head. I got some injections in the back of my head, and I was told, well, they should feel better soon. I went back to work, and literally within the hour, I had another one of these spells. I was in my office trying to hold my assistant back from calling 911 because I looked like I was going to die. And I racked my brain and thought, you know, what could this be? I thought either I'm having panic attacks and this is some kind of psych issue, because at this point I had seen multiple physicians. But ultimately what I determined was that it was probably a different condition. And if I was in the room, I'd ask for guesses. But I will just tell you that I thought I must be having a pheochromocytoma. And for those who don't know what it is, I'll tell you just a little bit about it. This is a picture of me standing right after my diagnosis was confirmed through these imaging studies and lab tests, holding a grapefruit, which is about the size of the tumor, about 10 centimeters, right about where it's located behind my liver. What clinched the diagnosis was actually the blood test that was ordered when I called my neurologist back and said, I know this is going to sound crazy, but I think I might have a pheochromocytoma. And she said, well, stranger things have happened. Let's check your blood work. My metanephrine levels, which essentially is adrenaline, came back at 30 times normal. And when they drew my blood at that time, my blood pressure was only 145 systolic, and I was feeling pretty good. So I was a little worried it might be a false negative, and then I wasn't going to know what was going on, and it was going to be a mystery. But no, sure enough, there was no question. And so at that point, once I got my lab test that confirmed it, I then needed to accelerate my workup, figure out, was this indeed a solitary mass, which thankfully 90% of these tumors are solitary and they don't spread malignantly, although they are quite dangerous. And it's estimated that 50% of people with pheochromocytomas die before they're ever diagnosed from these, because they cause these hypertensive crises and you get a heart attack or a stroke, and that's how they get you. But I was able to accelerate because of who I am and the connections that I have. I was able to accelerate getting a workup, accelerate a CT scan, accelerate an endocrinology visit, starting on the appropriate antihypertensive therapy, which is a specific kind of class of antihypertensives called alpha blockers that we don't typically use, but you have to use in this condition. And if you use beta blockers, in fact, it could be quite deadly. And I then had to find an experienced surgeon, and there's only about 1,000 cases in the US per year to remove these tumors, and they have to be done by an experienced hand. Otherwise, you can have a bad outcome. And even still, the rate of death, it's much better than it used to be, but on the operating room table, even in experienced hands, it's about a 2% mortality rate on the table. I ramped up therapy with my antihypertensive to get to the point where I had enough of a drop in my blood pressure when I stood up, so-called orthostatic hypotension, that I actually would almost become faint. And that's what you need in order to be able to get to the operating table and safely survive the operation. But for me to get to that point, I had to end up on equine doses of these antihypertensives, actually a higher dose than had ever been reported in the literature. So I was quite sick. Apologies to anyone who has just eaten, but this is my tumor selfie. You can't quite read the scale there, but that is in fact a 10-centimeter mass that my surgeon was kind enough to take a picture of as soon as he removed it from me. And so when I woke up, I was very grateful, first of all, to be alive, and felt very lucky. And I realized at that time that, of course, I could have died, and that others have, because and that it's not hyperbole to say that the reason I didn't is likely because of who I am. Being able to make my own diagnosis, or at least suspected, being able to then, advance my work up before something bad happened to me, and being able to identify an excellent surgical team to operate on me and cure me was really accelerated because of who I am and my connections. And that's not right. And that's not necessary. We should be able to do better than that. And so there are many ways in which my diagnosis, my care, and the future care of others like me could be improved through informatics. And that's what I was already working on. And it only made me even more committed to advancing this work. So several lessons emerged from this that have made their way into this evolving talk that I've given a couple of times, and I'm very pleased to be giving to you. And I'm going to walk through a few of them. The first lesson is that diagnostic errors abound. Yes, a rare disease, a particularly challenging one to diagnose like mine, often takes a very long time. In retrospect, I might have, we don't know it precisely, but I likely had this for maybe even 2 decades, and it was a very slow-growing tumor, certainly for many, many years. And part of the reason I realized is that we are taught in medical school that rare diseases are what we consider to be zebras, meaning that if you're walking around Ann Arbor and you hear hoofbeats behind you and you turn around, you're expecting to see a horse, not a zebra, because horses are the more common cause of hoofbeats in Ann Arbor. And so that's a nice way to teach medical students and others that common things are common, and your mind should not go to the rarest thing when you see a set of symptoms and signs presented to you. On the other hand, if you don't suspect it, you can't detect it. And so an alternative that's probably better is that when you hear hoofbeats, expect horses, but consider zebras, is probably a better way to go. And we know that diagnostic error is something that has been around for a long time. It's a problem even with common conditions, but certainly with more rare conditions. Clinically, I'm a rheumatologist. We certainly have this problem in rheumatology. We often make diagnoses of our patients with rheumatic disease years after they've started to have their symptoms sometimes, and they finally make their way to us, and then we're able to make the diagnosis. But, this is something that has been the focus of informatics efforts, with the development of expert diagnostic systems and capabilities, some of which are listed there in the center of the slide. And there have been, special issues of multiple journals dedicated to this. And this is an area of continuing work and much needed work. So we need to do better in this regard. Turns out at the time that I was diagnosed, if you put in my sort of classic triad of symptoms and signs that I had, hypertension, tachycardia, and headache, it isn't always the top hit, depending on your use of Google at any given time, but it's going to be on the first page, pheochromocytoma. And yet in the emergency room, that wasn't even considered. And it is common that such things are not considered. But, we have systems that can help us. And what we haven't really done is integrate them into practice and actually make our practitioners sort of benefit from these, but that is increasingly what we're able to do. The second lesson, and this is not going to be a shock to this audience, is that we don't actually have a learning health system today. We're all working toward it. But one of the realizations after this, on the heels of this, is that, well, we do have one way that we commonly learn about conditions like the one I had. It's, again, if I was in the audience, I'd ask for guesses. But if something really bad had happened to me, if I had had a stroke or a heart attack, or God forbid I had died, sure enough, I was a classic presentation of a rare disease in that emergency room, and it was missed, and they discharged me to home. And that very well could have been considered malpractice had something bad happened to me. And thankfully that didn't occur. But I think we can all agree this is a terrible way to learn. This is not the way that we want to be learning. And yet, sometimes we learn about the really catastrophic events this way, and that's not really what we want. So we want better ways of learning. And that's just one way to learn, of course, in the case of a learning health system, but it sort of exemplifies the issue. We know that we are, well into the second decade of trying to create, as you all are leading there in Michigan, the learning health system capabilities that we need for individual health hospitals and health systems, but also for the larger health system. And as in this publication, workshop summary from the Institute of Medicine, now the National Academy of Medicine, learning health systems are healthcare systems in which knowledge generation processes are embedded into daily practice to produce continual improvements in care. That's one of several definitions we could choose. But there have indeed been, many publications focused on how we can do this and how we can enable and drive it using data resources. And I promise you, Chuck, I didn't put this on here just because I'm speaking to this crowd. I add this to every slide I do, every talk I give about this, because I think one of the really important points is that back in 2010, when the Office of the National Coordinator for Health IT, and Chuck was the Chief Scientific Officer at the time, was working to really advance the agenda of getting all of us to adopt electronic health records. The vision at the time was, yes, we should be doing this in order to take better care of individual patients. But once we have a network like this, the goal really is a nationwide network that would enable us to advance also biomedical research, public health, and healthcare quality improvement, and really create a true learning health system. And that has been the explicit goal from the beginning. Again, your teams in Michigan have been leading in terms of really establishing a lot of the ways in which we contemplate and sort of think about the principles, and this virtuous cycle of data collected through practice, turning that data into knowledge, and ultimately that knowledge translating into represented knowledge that can be applied and change practice, all circling around a problem of interest, is what we are trying to achieve with our learning health system activities. And it's not an accident that data is represented on here many, many times, because it is in fact the sort of atomic unit of energy that really gets the learning health system moving. Again, we have a lot of different endeavors that are ongoing that in one way or another are connected to this concept of systematic learning and improvement, discovery, and then translation into practice, precision medicine activities, the All of Us program, the CTSA program with all of the different sort of elements of advancing translational science and practice, the Patient-Centered Outcomes Research Institute, and as I mentioned, EHR adoption incentives and others are just examples of national initiatives that in one way or another have really been focused for the last couple of decades really on driving us toward improvements in our infrastructure and our capabilities so that we can learn and leverage existing data for research and then quality improvement by taking advantage of the clinical phenotypes and outcomes, the administrative and fiscal variables, increasingly the biomolecular markers and the patient-reported variables, and of course beyond. But we have challenges in doing this because the way we've instrumented our healthcare system, it often is the case that we are collecting data in the course of routine practice for individual care and not necessarily with an eye toward being able to then repurpose these data for research and for learning and for the discovery so that we can generate more evidence. And that has been illuminated through various publications in terms of some of the challenges that we have, including the challenge of what we need to do to really take advantage of electronic health record data. And Bill Hirsch and colleagues wrote this paper a few years ago talking about some of the caveats of this, including that EHR data contain many inaccurate or incorrect data elements because they're sort of good enough for care. EHRs often don't tell a complete patient story. They just have to be good enough for the particulars of that encounter. Many of the data have been transformed and coded for purposes other than research and care. They often are captured and locked away in clinical notes. And while our natural language processing capabilities are improving significantly every day, and that's a good thing, it's still the case that a vast amount of the information we should be benefiting from is still locked away in text. EHRs may present multiple sources of data, and provenance is an issue. The granularity of the data in the EHR may not match the needs of particular research questions that we need to ask and answer. And there are differences between research protocols and care that get in the way of repurposing EHR data. But there, again, have been many initiatives, and this is a diagram from the Academy Health's EDM forum, where there was an inventorying of different initiatives that had, to that date, taken place to address some of the issues of how we can leverage EHR data for research and quality improvement. Again, we know that many of these, as listed here, have been in place for quite some time. And for instance, as Chuck said, prior to coming here to Vanderbilt University, I was in Indiana, where we had the benefit of one of the largest health information exchanges in the country. And those data were incredibly useful for being able to learn and advance our knowledge and then translate that into practice. Many of those activities engage clinicians and point of care activities, and we've made progress, but it remains very challenging. And many of those challenges are technical, yes, but not all of them are. In fact, I often like to joke, computers do what they're told and people tend not to, that usually we end up most challenged by the socio-organizational issues, the regulatory concerns, and the cultural issues that get in the way. And we face a lot of headwinds when we try to enable systematic research and learning by using our practice environments. And part of the reason for this is our current research practice paradigm. This is a diagram that I pulled from an article from 1998 about evidence-based medicine. This could have been any even more recent publication about the sort of idealized process of evidence-based clinical decision-making, which is to say that we generate evidence from research, we then synthesize the evidence, we develop evidence-based clinical policies, we apply the policies, and then when we're making individual clinical decisions, we take into account the patient's circumstances, the evidence, and patient wishes, and we make a decision. There's nothing wrong with this, and we should be doing more of it, and this is another area in which informatics approaches can help. But the point I want to make here is to call your attention to the unidirectionality of this relationship, which subtly and maybe even subconsciously really affects how we've designed our health system and or represents it, in that the relationship that everybody agrees is appropriate between research and clinical decision-making is that research informs clinical decision-making. But what we really want is that clinical activities also inform research. And too often, because of this flawed research practice paradigm, research and learning are often an afterthought, and organizational and regulatory confusion, such as pitting one ethical imperative against another, like the ethical imperative to maintain privacy and protect data, while at the same time we have the ethical imperative of leveraging those data appropriately for discovery, often are pitted against one another rather than being reconciled, and it leads to wasted investment and delays. And healthcare systems and how we're designed, how we actually pay for care, often don't involve the considerations of systematic learning and research, and so they often don't get done. They're not prioritized. And we often expect IT efforts to help, such as deployment of electronic health records. But again, the way we do that typically is not done with learning in mind, so that we have wide variation in the way that data are captured and collected, and we allow for a lot of variability because we aren't really thinking about the downstream use of these data. So the answer as we'll sort of continue to talk about, is captured again in a virtuous cycle, but it's sort of fundamental to what I've been saying, which is that clinical care activities must be recognized as not being entirely distinct from research activities, and not only in the sense that research informs practice, but that this concept of evidence generation or evidence generating medicine or evidence generating practice as a complement to evidence-based practice is really what we need to be focused on, both to advance science and advance care. And that, in fact, as I've alluded to, there are a lot of evidence generating medicine activities ongoing around us. And they are critical to finishing this evidence cycle. And then in order to make that work, much like the broader learning health system activities, as my colleague Philip Payne and I wrote in this article a few years ago, about a decade ago now, that there are enabling factors at the policy and organizational level, at fiscal and administrative levels, and at the informatics and health IT levels. And there are multiple stakeholders, from individual and local considerations and stakeholders all the way up to the national. And even back to my particular case, in the simplest form of learning, which is what did I miss? The absence of feedback loops is an example of this. As I mentioned, had something bad happen to me, there might have been word that got back to the emergency department at the very prominent health system in Boston that I went to when I had that spell. But instead, they would have had no way of learning about this, even though I ended up having the definitive procedure to make my diagnosis within 2 months, but it was in another state, and it was on the same electronic health record platform, the same vendor-based platform that was used in the emergency room where I had been seen. But they weren't connected in a way to actually exchange information for the purposes of learning. They are for individual care, but not for learning. So part of the issue is that we haven't decided to use these systems for learning. And again, Epic's Care Everywhere is a phenomenal technology that allows for exchange of data at the individual patient level between disparate hospital systems. But using that for learning is something that is only just now coming online, and it's really important. In terms of creating learning health systems, I've talked about informatics a bit, but I think to put a finer point on it, the way we think about this is that informatics approaches and capabilities are key to several elements. One is to instrument and optimize care and research data environments to enable discovery, knowledge generation, and evidence application, and to allow us to actually leverage a lot of the data, the analytical capabilities, and visualization tools around these different activities, ultimately to close that evidence cycle and continuously measure, evaluate, and improve at a systems level. Back in Indiana, in one of my roles there as the VP for Learning Health Systems, we worked diligently to try to really establish approaches for this. And one of the first things that we did was we got our academic and operational colleagues together to say, look, if we're going to create a learning health system here at Indiana University Health, and we want to learn from every patient, and we want to sort of build on this, what are our goals? And very importantly, we had the operational and clinical leaders and the academic leaders together. And we said, let's establish what are our common goals to make sure that we're driving in the right direction. And here's what we came up with. The first was that we wanted to learn from every patient, this idea that every patient care opportunity is an opportunity to learn. We wanted to overcome the fragmentation among our current units and committees that really worked disparately. And my favorite phrase that I coined a while back was silos of excellence. We have many silos of excellence. And I said that to recognize that there were silos, but that, to sort of throw them a bone. They were all quite good, but they were in fact siloed. And that's still an issue, even if you're excellent. To be disconnected keeps us from achieving what we need as a learning health system. We wanted to be able to scale and spread those things that worked. And so we needed to systematically monitor and study in order to know what we should scale. We wanted to improve care and satisfaction among all stakeholders. We wanted to improve processes, efficiencies, and outcomes and costs, and do that in an equitable manner. We wanted to accelerate discoveries and then the translation of evidence into practice, disseminate those beyond our walls, and then leverage learning health systems as a key differentiator. And this was one that came solely and squarely from the health system side. It was, hey, if we're going to put energy and time and effort into this, can we use it as a way to differentiate us and really communicate to our community that we serve that, you want to come get care here because we're better for being a learning health system. And so when we think about creating learning health systems, there's a lot that's been written about doing this nationally, and a lot of thought's been given to that. But doing it locally is something of a different activity, and yet these are tightly connected to one another. And we know that, yes, there are informatics and health IT considerations to doing this, but there are also, very importantly, people and cultural issues that have to be addressed, issues of systems and workflow that have to be addressed, and then the alignment of incentives, including fiscal incentives that are important. And once we do this, of course, we do have to keep an eye on connecting to others and creating regional and then national learning health systems. And again, back in Indiana, we were able to do this in part enabled by the infrastructure of a common health information exchange, which was already an apparatus for exchanging data and knowledge across systems, although sort of taking it to the next level and creating regional learning health systems was, on the roadmap of things to accomplish. Okay, third lesson. Beyond the clinical data that we have that we've been talking a lot about, it's really critical to recognize that other data are essential to really understanding and achieving improvements in health. And this is, of course, a generic diagram, but the point of this is that it roughly approximates what we sort of guess is the proportion of elements that actually correspond to one's health. So at any given point in time, the health care that you get accounts for, more or less your current health status. For most of our lives, health care isn't really the primary element that sort of speaks to our care. Our genetics, our environment, our social environment and social factors, and our behavior are really, really critical. And so if we're really going to understand health and we're really going to be able to improve it, the data that flow around us are related to these other elements are also important to capture. At the time that I was between my initial diagnosis and my operation, I would argue my healthcare data was a very accurate representation of my health status for that period of time. But prior to that and afterward, my health record is probably not the best indicator. It's a lot of these other things. And case in point, when I was diagnosed, Apple had not yet added this feature to its watch, but I had been wearing an Apple Watch, and I was able to go in and interrogate that watch and download my my heart rate. It hadn't alerted me, but when I looked at it, there was actually not a day that had gone by for the year that I had been wearing that prior to my diagnosis where I did not have multiple episodes of resting tachycardia over 120 over that period of time. And, had that been the case, it might have prompted me to, to go in and get care. On the other hand, if I had taken the output of that and put it in front of my clinician, I'm not sure what would have happened. I know as a clinician, if my patient brought me, a bunch of an Excel spreadsheet with a bunch of heart rates on it, I'm not sure that I would have known what to do with it. And we have work to do in order to make sure that we can actually leverage these data and others for the purposes of improving care and creating learning systems. Similarly, we are surrounded by increasingly smart devices and smart cities that are capturing information, much of which probably does, in fact, have relevance to health. And we have only just started to scratch the surface in terms of how we should be leveraging these data components to potentially improve our understanding of health and make it better. Well, everybody loves an ohm, and so we often talk about the exposome in this regard. Of course, there's the phenome, the clinical data, and the representation of your phenomic characterizations that we often capture in electronic health records. There's the genome, and of course, there's now others like the microbiome and the like. The exposome speaks to the structural, environmental, social, and behavioral data that are increasingly available and are very relevant to this question. And in the field of informatics, we are sort of working across the phenome, genome, and exposome to integrate these data with a variety of methodologies and leveraging and integrating data sources. We know that this is a challenging thing to do, but it's an important thing to do. The fourth lesson then is that I've alluded to this already, is that creating learning health systems is in fact a socio-technical challenge. It is not just about having good technology and having capabilities to capture data and represent it. But in fact, the socio-organizational factors are really critical. And I won't belabor this because I think I've made the point, but these various variables and alignment of incentives and addressing societal concerns is equally important. And we have to, again, address that at multiple levels. So I'll pivot here to just talk a little bit about, of course, the topic of the day is artificial intelligence. And of course, many of us have been working in this area for quite some time, but there's no question that this is continuing to grow in relevance and I think has an important connection to the learning health system. So here I will start by presenting again Chuck's fundamental theorem of biomedical informatics with the basic idea that a person augmented by computational technology should be able to perform better than that person who is unaided. And it's a very basic but very fundamental and really critical theorem that has stood the test of time. Computers are really good at helping us do certain things. In theory, AI-enabled computers should be even better. So with Chuck's tolerance, I joke that we can update this by adding AI to the picture, and an AI-enabled computer should be better than a computer without that. And we'll see if that remains the case as we proceed. But for those who don't think about this perhaps quite as often as the rest of us, just a very sort of basic idea of how it is we actually create AI algorithms. We first have to start by acquiring data and actually training models. And so the data that we acquire are really important in terms of their scale, their diversity, their volume, and their fairness in terms of being representative of what we're trying to accomplish. But we also know that data are derived from the systems that we run as humans and in society. And so therefore they can inherit societies and systems biases, and we have to keep that in mind. We then train these models using various methods to create either the what we think of traditionally as analytical or predictive models, but increasingly, of course, we've been working and people are more familiar with generative models as well. But in either case, we're training based on data, and then we're creating these algorithmic models, be they predictive, analytical, or generative, and then we deploy the models. We put them into practice. And we then test to see whether or not they are going to improve the outcome of interest. What we tend not to do quite so much, and we've been working a lot on here at Vanderbilt and are continuing to advance, is the approach to monitoring, because we know there are biases, we know there are challenges. And we know that because, increasingly there are publications that have sort of demonstrated that algorithmically driven healthcare, if not monitored and studied, can have unintended negative impacts. And a very famous example at this point now is by Ziad Obermeyer and colleagues from 2019, where they detected racial bias in an algorithm that came out of Optum Labs, where they had made an assumption about healthcare utilization represented in the fiscal data that they had and the utilization data that they had as being the appropriate surrogate marker for disease burden, when in fact they didn't recognize and think at the time, they just didn't realize that that makes sense if everybody has equal access to care. But if they don't have equal access to care, then healthcare utilization doesn't necessarily mean more utilization means more disease burden. It could also mean more utilization means more access, and less utilization might not mean lower disease burden. It might actually just mean less access to care. And sure enough, when it was tested, it was harmful to, for instance, Black populations that had systematically less access to care, and therefore was guiding the system to provide less care to those patients, and that likely resulted in harm. They corrected that, but it was a good example of unintended consequences. And there have been many articles written since about other ways. And the point being, we need to monitor these algorithms in order to really know, and a learning health system approach is the way to do it. Now, again, just to drive this point home, why? Well, there are biases in the data, importantly, those that we know about, but also those that we don't know about. We have to be cautious about generalizability of algorithms when we deploy them. Just because an algorithm developed here at Vanderbilt University might work very well in our population, in our workflows, in our health system, if we were to take that and then deploy it at the University of Michigan or Michigan Medicine, it's not necessarily going to have the same effect. We can't assume that. We have to check for it and test it. if we can expect anything with any technological intervention, time and history has taught us that it's the unexpected we can expect. We have to do this in order to promote trust among, of course, those that use the systems, but also importantly among society and our patients. And we have to create new systems and approaches in order to do this, because it's essential for safe, effective, efficient, and equitable care. Borrowing then from the concept of pharmacovigilance, many years ago now, about 4 years ago, I was sitting on a panel where somebody said, well, these AI tools are increasingly being deployed. And, what are you worried about? And I said, well, what I'm worried about is that we're not monitoring them. I just said, much like pharmacovigilance, we probably need something like algorithmovigilance. And so taking the idea of pharmacovigilance, the science related to the collection, detection, assessment, monitoring, and prevention of adverse effects with pharmaceutical products, and the various sort of evolution of this as a discipline and a set of practices that have evolved, we can take the same idea. And I wrote about this a couple of years ago now in this article where we talked about algorithmovigilance as the scientific method and activities related to the evaluation, monitoring, understanding, and prevention of adverse effects of algorithms in healthcare, akin to pharmacovigilance. And we are now working to sort of do the following, which is to take this concept of rather than stopping at deployment, where we develop algorithms based on data, we study them in selected populations, and we deploy them, we're actually trying to create now the mechanisms and capabilities for this learning health system approach to algorithmic monitoring. The way we're doing that here at Vanderbilt is in this way. We have the mission control sort of dashboard that we want to create. And this is a cartoonish representation of what we are now building here, which is a way of tracking and monitoring these algorithms that we have in practice here, measuring across various example metrics, looking for accuracy and precision, drift, responsiveness to the downstream decision support alerts that are often driven by these, and then measures of fairness and equity, and looking at whether or not they go beyond some set bounds, having feedback mechanisms, both from those in the field that might identify things, but also back to them and back to those that are managing the systems to be able to address any issues that arise, and starting to articulate what possible actions would then result when we start to see things go out of bounds. Of course, investigating the cause, figuring out whether we need to correct and update the model if there's been drift, notifying the teams, and maybe even pausing the algorithm if it's causing trouble. And then once we do this, if we take the concept further, and increasingly we're thinking about this in the case of creating assurance labs that can actually work across multiple systems, we have local algorithmovigilance capabilities, like at Vanderbilt, where we would then have governance and oversight, technological and human-driven monitoring capabilities, our ability to respond to issues and capture and report events. But importantly, then, we might see an evolution, much like a learning health system approach, where we then have a central system that can actually draw from multiple. So, wouldn't it be great if we started to identify an issue with an algorithm here that was also running in Michigan, and you all would then be able to benefit from that, because we could say, well, look, we're starting to see a problem here, keep an eye on that, or in various ways start to identify adverse effects that might then lead to us perhaps doing the equivalent of a black box warning, or even a withdrawal or an adjustment. We're also doing other work with collaborators, looking at how we really look at AI readiness. So we have a grant from the Gordon and Betty Moore Foundation to develop a capability and maturity model for the use of health AI in practice and across health systems. And so along with our colleagues at Duke and with the Coalition for Health AI, we're working to characterize the landscape of readiness and create a maturity model. The preliminary domains, this is an ongoing project, but the preliminary domains at this point are likely to include some of these: governance and leadership. What is the level of maturity that individual health systems have with regard to their governance and leadership of sort of AI solutions? To what extent is their maturity around the infrastructure and capabilities for data quality, availability, and representativeness? The technological infrastructure maturity, the maturity around skills and competencies, around the acceptability of AI in practice, there are likely specialty level considerations that have to be taken into account. We see a lot of progress, of course, in the areas of radiology and cardiology, and we're seeing evolution in other areas. Maturity around our capability regarding ethics and health equity, and then our algorithmovigilance capabilities as well. So that leads me to the fifth and last lesson, which is that, which is really where I started, which is that informatics not only can help, but really must help to create this virtuous cycle, this learning health system. We need to be focused as informaticians on supporting our data and AI-driven learning health systems for discovery and care, to enable automation, to improve prevention, diagnosis, and treatment, to enable transparency. You know, I was able to figure out, for instance, where I could find a good surgeon for my particular condition. That's not an easy thing for the average consumer to identify, but we can make it easier and better. To identify and improve health disparities and health equity, to accelerate discovery and translation into practice, and ultimately empower people and systems to improve their health, so we can create this virtuous cycle that will improve healthcare, quality research, and overall health. And we have to do this with a sense of urgency, because people are suffering, and they're suffering needlessly. And again, you shouldn't have to have an MD and be well connected like I was to be able to get great care. Our system is not working for far too many people, and we need to act to fix it. And where it isn't obvious, we need to innovate. This is an image that's actually hanging in my office by an artist named Mike Natter, who actually now is a practicing endocrinologist. At the time that he drew this, he was a medical student, and Mike was an artist before he went to medical school. When I got diagnosed with my pheochromocytoma, I found an image of his on the web, and I bought his first print of his pheochromocytoma Hulk that he drew during medical school. I had all of these symptoms, and I occasionally turned into a green rage monster, but now I'm just a mild-mannered scientist again. So very happy to be that. With that, I will conclude, and I think we still have a little time for Q&A, so I'll turn it over to Chuck, and I will take this off the screen so I can see him, and thank you all for your attention.
Thank you so much, Peter. This really was very provocative, and I'm looking forward to some really interesting discussion. We have some questions. The first, Peter, what is your opinion regarding very large data sets such as Epic's Cosmos and Oracle's CRWD for quote-unquote patients like mine to deliver one form of real-time feedback for diagnosis or care delivery options related to your point mid-lecture on feedback loops?
Yeah, great question. I think there's enormous value and capability there. I actually had the pleasure back in 2012 of being on the first advisory committee to Epic, being the chair actually of the first academic advisory group to Epic when they were starting to plan for what is now Cosmos, and we established some of the early rules of the road, and have kept in touch with those folks. And since then, in fact, after my diagnosis, I reached out to them and said, you know, you have this capability for being able to exchange data, but it's at the level of individual care. We really need to be focused on how we can do this for learning. And I think there is a lot of potential. We haven't realized it yet, but I think there's a lot of potential. And I think what you point out in terms of patients like mine is a good example of how we should be using that moving forward to be able to inform practice. There's a lot of work to be done in order to realize that and make it, by which I mean make it real. But I actually think there's a lot of great potential to doing this, and I think we need to do it, and it should be something that we actually put more energy and time into, frankly.
Dwelling on that question for a moment, Peter, patients like mine is a term that people in informatics use to describe a very elegant approach to learning and care improvement. Do you want to describe what's meant by that?
Sure. So, you know, traditionally, the idea of how we would sort of inform the care of a patient in front of me as a clinician is that I would say, well, what does the literature say about this? And that's still, of course, what we should be doing, right? So what is the evidence for how I take care of this patient? but we recognize that for many of the clinical questions that come up, we actually don't have good solid evidence from the literature. Where we do, we should use that. And, you know, the highest level of rigor and of evidence that's available should be what we apply to that patient if it's applicable to that patient. The idea of patients like mine is, with this large data set that is increasingly interconnected, you know, if I'm sitting across from a patient with rheumatoid arthritis who is a particular age, particular demographic background, particular set of comorbidities, particular sex, what have you, and I'm about to start therapy, and there isn't, there's sort of a generic recommendation, but there isn't a specific recommendation. Is there some way I could tap into that large database and say, well, tell me about all the other patients like mine who resemble this patient, and how have they done with this treatment, or how have they been worked up, or whatever you, and then can we bring that knowledge to bear, even if it isn't yet in the form of a peer-reviewed publication. So that's kind of the idea, is, you know, leveraging this large data asset to be able to say, well, how have other people like the one I'm looking at fared when I take a particular action, and then, you know, how can that inform my care at this moment?
Thank you. Okay, another question. From the perspective of efficiency, it is reasonable to spend energy on trying to improve accuracy of EHR data, both in content and to the level of detail necessary to use that data for clinical research. In other words, can we wed patient care and clinical research? Does AI have the solution to this, or point the way to the solution?
Yeah, another really great question. Thank you for that, Ed. So I absolutely think so. I think I think we have several challenges. One is that, of course, we know that clinicians are already incredibly burdened with documentation burden. And so one thing we can't do, and I want to be very explicit that I never advocate for just adding additional data collection on top of what people are already doing, because we know that's not going to work. And more than that, we'll get, you know, run out of town on a rail. So what we really want to do is say, and I think there are ways to do this, is recognize, first of all, that it's a false choice to say, well, we either collect better data or we decrease the burden. I think there have been examples, but we need more of them, and we need better methods where we can actually go back and say, you know, what if we fundamentally modify the way that we are actually collecting data at the point of care, not only to make it more useful for the purposes of downstream research, because now we're thinking about doing that, but also in the context of doing that, we actually either don't add to or frankly reduce burden. And to the second part, I do think that there is potential, if we really work hard at it, that AI solutions can help. What I am a little concerned about with the rush toward the adoption of generative AI approaches to decrease burden is that while they may benefit us in terms of offloading some of the documentation requirements of individual humans, we could end up with even worse data, just a lot more clutter and a lot more not as useful data. And so I think this is a moment in time where we really need to emphasize that this is an opportunity to say, how have we been documenting? How should we be documenting? And how do we do that in a way that lowers burden and increases the value of the data that we're collecting, so we can use it for multiple purposes, including research?
Okay, sitting on that one for just a moment, there is much said these days about the burden of documentation and other data gathering activities that fall upon not only physicians but all care providers.
Yes.
Do you think, Peter, if we achieved a learning health system and it became evident that those data were leading to value achieved through the analysis of practice generating data, as you call it, that might be an ameliorating factor in this almost crisis situation we have now with physician burden?
I do, because I think something that isn't talked about quite as much as perhaps it should be is it's not just the act of documenting. I mean, we as clinicians, we've always had to document. We've always spent a significant amount of our time doing that, and capturing good information in a medical record is an important part of the job. So I don't think it's per se that we don't want to do any documentation. What we want to do is know that we are documenting for a good purpose. And right now, so much of what we do is actually driven primarily by, a regulatory need or a need to get paid and be able to sort of satisfy the requirements of the payer or the downstream attorney or what have you, rather than focusing in on the real value of collecting good information. And I think, to your point, if we could increasingly demonstrate that the reason we're doing this is because it's going to improve our ability to take better care of not only this patient in front of me, but the patients that are going to come back tomorrow, and that we're going to learn from this, well, now it provides us with the impetus we need to say, okay, well, then if we're going to do it for that reason, what should we really be doing? And yes, we have to have better we have to focus on communication and learning, and therefore now there's a reason to be doing this. And now we can actually benefit from the activity of documentation. I won't go into it in detail because of time, but I've done some of this work where we actually modified the templates to create some consistency. And the result was improved satisfaction, no increased time in the visit, and better data to be able to actually do research and improve care. So it can be done. It just needs to be done in a more systematic way.
Thanks. As we move toward the top of the hour, I just want to say we are scheduled in this session to run past the top of the hour. I just want to be sure you're able to stay.
Thank you. Yes, I just had an assumption that we were stopping at noon, but let me double check. But I believe we're good. If that's what we're scheduled for, I am. Oh, yes, I have plenty of time. No problem.
Okay, good. So, Peter, in your case, where you had an interaction in an ED and surgery in a different hospital, how would you envision the ED team getting the feedback they need to improve?
So I'll tell you the way I did it, and then I'll tell you how I think it should happen. Again, because of who I am, I picked up the phone and called my friends back at that hospital and said, can I speak with the head of emergency medicine? And when he picked up the phone, he didn't know me. And he said, okay, thanks, Dr. Embi. I'm a little busy. Can I look at your chart and call you back? I said, sure, take your time. And I got a call back in about 5 minutes because he looked at my chart and said, oh, yeah, we missed that. And I said, no, I'm aware. That's why I'm calling you. So then what he said was, well, would you be willing to talk with the doctors who took care of you? And I said, no, absolutely. That's why I'm calling. I'd like to speak with them. When I got them on the phone, they were appropriately very apologetic, but I said, look, guys, I appreciate that, but that's not why I'm calling you. I'm calling you for 2 reasons. One, I want you to know that you saw a pheochromocytoma, and that's pretty cool. And you should know that, and be aware that that's actually what you saw, not a migraine and hypertension. And you might want to share that with your friends. And number 2, I want you to be aware so that you can maybe look at your processes and your practices. And I just wanted to give you that feedback. I want to close the loop with you. That is not scalable. So that is not the way to do this.
I was hoping you were going to say that.
Yeah. So the scalable approach, of course, is one where, we, in fact, work with our systems. So I am not here to tell you that I figured out how to do this, because I haven't, but we've contemplated various approaches. So one is, for instance, as I alluded to, I subsequently had the operation at another institution, same system. One could imagine, now, one of the reasons why these data don't get exchanged, there's lots of reasons. One of the reasons why these data don't get exchanged sort of automatically is that, there's still a requirement for some permissions that have to be granted for actually exchanging data back and forth. But, that can be facilitated. And so if my surgeon, for instance, where I had my operation, had come to me and said, hey, you know what, it turns out we have this system where, because you recently got care at, 1 or more other facilities, if you will allow it, we will push your data or we will push some kind of message back to those institutions so they can be aware of this. Is that okay with you? I would have consented to that. And then, there could have been a facility that actually allowed for that. You might imagine that there's an opportunity for even pooling data, because I could have given consent on the front end to allow for the institution with the emergency department to say, would you mind if we query the interconnected system across the nation for the next year to see whether you get care elsewhere, so that we could learn from whatever we might have missed. I'm giving you two little examples of ways I've contemplated how we might instrument such an ability to have learning across a network. And I'm sure there are others that can come up with better ones, but I think there are ways to do this that would be scalable.
Yeah, that was a terrific question. Really went to the nub of your story and how it relates to the learning health system concept. Okay. How do we manage data differently? Should we manage data differently for newer AI work compared to what we've been doing for the past decade or earlier?
That's a great question. I think my first reaction to that is that there's a connection to what I've already said, which is that in the same along the same vein of what we've been discussing, which is that if we recognize that one of the reasons why we are collecting data is not just to take care of this patient in front of me and communicate with the other providers that are going to be caring for this patient today and tomorrow, but also to be able to systematically learn. I think that if we look at it with the same attention, which is to say, we also want to be able to leverage AI capabilities, and here I'm thinking primarily about predictive and analytical AI capabilities, then in those cases, we might say, well, are there ways in which we need to be capturing data that can actually help us better utilize and leverage and optimize the use of artificial intelligence capabilities? And I think, again, if we do the exercise of thinking about what we want to do with the data, then that leads to an understanding perhaps of how it is we need to be modifying the way we're collecting and then managing the data. The management part of it, of course, is about more than collecting it. And that's a really good part to this question too, which is that, where it's housed, how accessible it is, who can access it for the purposes of developing algorithms and the like is also important. And one of the things that we're really challenged by right now in terms of creating algorithms and then deploying them and testing them and making sure that they work well is that our data are very hard to get at, and good representative data sets that actually can help us not only develop algorithms, but then test them across multiple different populations that are appropriately diverse and representative of our communities in which they're going to be applied are hard to come by. And so I think one of the things that we are working on, but we need a lot more work on, is the development of capabilities for privacy-preserving capabilities to access data that can actually then be made available to the developers of AI solutions, to the testers of AI solutions, and the ongoing monitoring of those. So I think there are numerous ways in which we should be really revisiting the management of data in this AI-driven world. So that's a great question.
Okay, well, the hits keep on coming here. A question regarding how we assess knowledge quality learned from our learning health systems, such as racial bias. For the evidence / knowledge from clinical trials, we have a grading system to assess the evidence level from the trial design perspective. For real-world evidence generated from EHR and other sources, how should we assess the knowledge quality, and how should we choose which real-world evidence to implement in the LHS loop?
A great question as well. There's some work that's been done on, so one of the ways that we test evidence and sort of check evidence is, various criteria that have been established, for instance, in the publication world around, what should be reported when we are, for instance, reporting, a study in the literature. And depending on the type of study, there are various, the consort criteria and various other criteria that have been established to tell us, here's what needs to be reported. These are the elements that are required in order to be able to validate and understand how sort of solid the evidence is and be able to replicate that, et cetera. And there's been some work around real world evidence in that regard. And so I would first start by sort of looking and pointing you all to that. But I think what they speak to is the broader sort of aspects of consideration that will include things such as, first, good characterization of what is the underlying population that these data represent, and having good characterization of those populations, really understanding the data and where they came from, the provenance of the data, the context in which it was collected and for what purpose is also really important, because it often helps us to understand where it may have some inadequacies or what have you. And then there are measures of missingness and other kinds of capabilities that we have at our disposal that we need to bring to bear in terms of assessing this. At the end of the day, the quality of data is part of what you're talking about with this question, and measurements of data quality fall into multiple different categories. And a lot of, some of us like to say, data quality is in the eye of the use case. So it sort of depends what it is you're trying to do with the data in terms of how good it is, because even data that might not be fit for a certain purpose might be fine for another one. So we have to get more sophisticated about that. But there are some places to start that I think we can build upon.
Okay, just staying on that one for a second. This question, in a way, goes to knowledge quality as opposed to data quality. And clearly, data quality increase will result in an increase in knowledge quality, all other things being equal. What other factors, Peter, in your opinion, will contribute to knowledge quality besides data quality?
Well, it's a great question. So I think in a similar way, one way to think about this is the way that folks have been starting to talk about this, and certainly some of us who are involved in the MCBK community, the Mobilizing Biomedical Computable Knowledge community, have started thinking about this, and others are talking about, for instance, the equivalency to like nutrition labels and other kinds of ways of actually characterizing the knowledge objects that we're talking about. Where was it developed? What data went into developing the knowledge object? That's very important to sort of understand where it came from, who built it, for what purpose, and to what extent is it available and able to be deployed into various environments. So I think looking at that work that's been done around nutrition label equivalents for algorithms and knowledge objects is one way to do it. I think at the end of the day, a fair amount of the real, so a lot of this is about sort of process measures, if you will, but the outcomes of how these objects actually, these knowledge artifacts actually work in practice, and the degree to which they are effective at achieving the outcome, and then how well that effectiveness is sustained and how generalizable it is across deployments is also a really important point as well that also needs to be taken into consideration. So I think there's levels in terms of assessing quality and of the knowledge objects as they're developed and as you're interrogating them, but then also I don't think that substitutes for the ongoing monitoring of the effectiveness of it, which goes back to my sort of push for algorithmal vigilance.
Yeah, great. Thank you. We got two more. You got energy for two more?
Yeah, let's do it.
Okay. Does your institution do any outreach to providers when proposing changes to workflow to increase value of data collected? I have found that provider resistance to change is often the biggest barrier, and I've had some success with the issue when I can go to department meetings and discuss what we are trying and currently failing to do with the data with respect to research.
Yeah, it's a great question. So here we have the benefit of having the Vanderbilt Clinical Informatics Center that is run by my colleague Adam Wright and group. And one of the things that they've been focused on now for some time is that, which is to say, going out and actually determining, what is valuable, what is not valuable, and engaging with clinicians. We also have a group of clinical directors in health IT who are informatics trained clinical informaticians who work within our health IT group, who are actually the engaged parties that extend, if you will, the CMIO network out into the various groups. And while I'm sure we could do it better, I think that those are examples of sort of the apparatus that gets to what you're talking about, which is absolutely correct, and I would agree with, which is that, you know, engagement and beyond just engagement, input and actual involvement of end users is really critical to the success of any of these kinds of efforts. So I would agree.
Okay, actually, there are still two more.
Okay.
One more period. As of now, EHR data include basic demographics and mainly medical diagnostic data. If we are to include environmental and behavioral data in EHRs, what would we like to see in them? What would we like to see in them in order for them to be useful?
Yeah, good question. So first of all, I think I think the jury's out on whether or not the right way to incorporate environmental and behavioral data into our larger data set is through the additional collection of those data at the point of care and at, you know, the time of registration and various other ways. I think there's a benefit to that, and there is probably some value to that. But I think that, you know, one of the other ways in which we need to simultaneously be doing this, I think where it makes sense in the workflow and it's appropriate to collect additional information about people's home environment and other socio-demographic factors at the point of care, we should do that. And then there should be ways to capture and put that into the EHR, and there's work going on there. But beyond that, augmenting the data resource with readily available data that is already around us and that we can then pull in, some of which is not at the level of the individual, but maybe at the level of the census tract or the zip code or what have you, is still valuable. And integrating that with the clinical data, I think, without additionally burdening people in the health system or the patients, is also doable. And I think there's evidence from other studies that have shown that when you combine these data that are out sort of publicly available with the clinical data, and then you use that, for instance, to develop algorithms to be able to then drive, for example, some good work out of some colleagues in Indiana, where they took these data and actually used that at one of our hospitals there to show that by alerting clinicians at the point of care in a diabetes clinic that their patient might be living in a food desert or might be living in a socioeconomically depressed area, they might actually benefit from a referral to nutrition or a referral to financial services or a referral to, or even just a cab voucher so they can make their next visit, that these actually led to improvements in outcomes for those patients. So I think integrating data that are around us, perhaps not necessarily into the EHR, maybe into the EHR, but into some common data set that then make their way back to be able to deliver decision support, I think is absolutely something we should do.
Okay, one more, and I promise this will be the last question.
All right.
Okay, and it's a good one. Using AI to aid in diagnosis is likely to expand the differential, and this could increase imaging and lab orders and clinician time to process the information. Are health systems going to allow additional time for clinicians to accommodate this process?
That's a great question. I don't know. So we can just stop there. No, I'm kidding. I think it's a really good question. First of all, I think your premise is perhaps correct, but that's testable, right? Is it actually going to, yes, it will expand the differential diagnosis. It theoretically could really shorten the diagnostic odyssey. I think that would be the goal, right? So if in fact, yes, you have a short differential diagnosis currently, but we keep missing diagnoses. And so people have to come back over and over again. And finally, after months or years, they get their diagnosis. Well, that's been wasteful. And so if we could demonstrate that by doing some version of what we're talking about here, we actually shorten that diagnostic odyssey, maybe it increases the burden and time for that particular encounter, but maybe it leads to more accelerated diagnosis, better outcomes, and actually opens up more capacity in the health system overall. I think you'd need to take a holistic approach in order to know whether the economics of this ultimately makes sense. But I think in addition to cost, there's also cost effectiveness, and I'd like to think that those who run the health systems would want to look at it that way. But I think I just said a lot of things that require a lot of assumptions and a lot of evidence and proof that we don't have. So I think there's a lot of research to be done to really see whether we could realize that vision. But that would be my hope for the approach.
Well, Peter, thank you so much. I think the greatest testimony to the quality of a presentation is the quality of the questions.
They were excellent.
That it generates, and I'm really struck by the quality of these questions, and I think that's largely attributable to the quality and insightfulness of what you presented. So we're very grateful to you for what you shared with us today, and we're grateful that we're going to have a recording of these proceedings for others to see in the future. So thanks to everybody who attended today. We had about 120 people at the peak. Please use this QR code to complete a post-event survey. We value your feedback, and in a learning seminar system, we do make changes in how we run things at the collaboratory based on this feedback. So please take a moment to do this. Happy holidays to everyone, and we will see you at our next event, which will be on January 16th, 2024, with more details to follow. And I have to say, go blue. By that time, we'll see who the national champion is, but we're very much in the running. And some other team isn't.
It's all right. I'm not contractually obligated to root for them anymore, so it's fine.
Oh, okay. That's good to know. So thank you again, Peter. Happy holidays, everybody.
Thank you. Likewise. It was a pleasure. Thank you all.